Hello, everyone. Welcome to today's session on magnetic effects of electric current. So earlier we learned about electric current, right? So in today's session, we will look at what magnetic effects that electric current produces. Okay. So for that, first let's understand this experiment. Okay. So what is a magnetic field, right? So in general, we know what is magnetic field. If we have a magnet, right? For example, if we have a bar magnet, right, which has like the poles south and north, surrounding this, right, we will see some force, right? Like if you keep a magnet, any metal near the magnet, it gets attracted, right? So what basically is surrounding a magnet, it exists a field that is a magnetic field, which can attract the materials, right? The metals. So we know in general what is a magnetic field. Now, if a current is passing through a particular conductor or a wire, there are some experiments which have proved that there exists a magnetic field. So let's see how that is, right? So let's understand this experiment. This is from your NCERT book, right? So what we need to do is there is a circuit here. We have a battery, right? With certain voltage V, right? And we have an ammeter to measure the electric current, and there is a resistor, and then there are two ends to this, right? So one end is X, the other end is Y. Here we have connected a wire. Okay, it's a conductor. Conductor means which can pass electric current through it, or any copper wire or silver wire, whatever, right? And then it is connected to a key. Now, when a circuit is on, when the switch is on, the current will flow through this, right? So you can see some reading in the ammeter that the current is flowing, and then it passes the resistor, and then it passes through the wire X and Y. So when we see X and Y, there is one setup, it is kept here. So what we need to do is we need to place a compass near this, right? So at the middle of the wire, you just put some cardboard or a paper or whatever, just to ensure that to see how that magnetic effect is being created when the current is passing through this wire. So if you keep a compass, you can see there is a deflection, right? So what compass helps in detecting the magnetic field, right? Magnetic field lines. And the compass, the default position is north south. Okay. So when there is a deflection, that means when the current is passing through this conductor, we see some magnetic field surrounding it. So that can be measured using this deflection in the compass. So that proves that whenever there is a current carrying conductor, surrounding that material or that wire, there exists an magnetic field. And how we came to know that? When I place this compass near to that wire, so I see a deflection here. Okay, so that proved that whenever the current is flowing through a conductor, they surrounding that conductor, there exists an magnetic field. Okay, so that's the magnetic effect of electric current. So what we concluded here, when a current I, right? So this is the current I, right? When current is passing through the, so we can say when current is passing through a conductor, when a current is passing through a conductor, comma, there exists there exists an or a magnetic field surrounding the conductor. You understood? So whenever there is a magnetic field passing through the conductor, whenever an electric current is passing through the conductor, it forms an electric field. surrounding it that we have observed in this experiment using a compass. Okay, now let's look at how these magnetic lines are formed, right? So let's see this experiment now. So here, what we are doing is we are fixing a sheet of white paper on a drawing board using the adhesive material. So basically, we are keeping a drawing sheet. On top of that, we are placing a bar magnet. So this is the bar magnet, which has both north and south poles. Now, place a bar magnet at the center of the sheet, then sprinkle some iron filings uniformly around the bar magnet. So some iron, that small pieces, that is called iron filings, right? So small pieces of iron, if we sprinkle onto that cardboard or that white sheet, where this magnet is placed, so what happens is those sprinkles, if you see here, they attract to the magnetic field and they form kind of a, see, if you see here, near to the magnet, it forms into this particular shape, right? So from here, like this. So those sprinkles arrange themselves into this shape, okay, because of the magnetic force that attracts towards the magnet. So what we are seeing here, it is basically, that is how the magnetic lines are formed surrounding the magnet. Understood? So if we draw this, how this reflects is, right? So I have a bar magnet here. That's the north and south pole. So basically what happens is the magnetic field lines will form like this. Yeah, I'm drawing it roughly from north to south. And from here, it will be like this. Always the magnetic lines are from north to south, like this. So you understood? So the magnetic lines are like this. So what we can also observe here is the magnetic field strength near the magnetic poles is very strong. So near the magnetic poles, the North Pole or the South Pole, the magnetic field strength is very strong. And as we move away from the magnet, the field strength slowly reduces. You understand? Let's say I have a bar magnet on the table. So if I keep a coin near to that, it immediately attracts. If I keep that very far, like at the edge of the table, it may not be attracted. That means the magnetic field strength ceases as we move away from the magnet. So here the strength, so the ability to attract the materials, the magnetic ability will be more at uh, the places near to the magnet, particularly at the north and south pole. As we move away from the magnet, the strength of the magnetic field reduces. So what we can say here is number one. So the magnetic field strength, magnetic field strength is very high, is very high near the magnet, particularly north and south poles. And the magnetic field strength is low. The magnetic field strength, we can say, reduces, right? It reduces as we move away from the magnet, away from magnet. Understood? So these are the behavior of magnetic field and also the magnetic field line. So this experiment gives an idea how the magnetic field lines are formed surrounding a magnet. Okay. Next, in the next experiment, we will exactly draw how we can draw these magnetic field lines. Okay. So here, if you see uh, to the right, I have two pictures here, right? So If you see here, I have two pictures. So this is a bar magnet, and this is the shape of the magnetic lines. Okay, now let's see. I have a magnet here. So what I need to do is same thing. Let's put this bar magnet at the center of a white sheet, drawing sheet, and surrounding that, what we need to do is, so I have the bar magnet here with North Pole and South Pole here, and here near the uh, magnet, you keep the compass. Okay, so here, if you keep the compass, right? So it shows which direction the magnetic field is, like north to south, right? So whichever the direction it indicates, you can include a cross mark there. And then you move to the next. So there you will see the compass needle is deflecting in this shape. All the dots here, like this is how it deflects when we move the compass around different positions surrounding the bar magnet. So that says the bar from the bar magnet, the magnetic lines are moving from north to south. That's the direction that it shows, right, in the compass. So from north to south, as in the below diagram. So if you see north to south, so the magnetic lines are moving from here to this side, and here always from north to south. So here if you see at the poles, the strength is high, and as we move away, even the distance between these is increasing. If you see the distance between the magnetic field lines, two consecutive field lines, is increasing because the field is getting weaker and weaker as we move away from the magnet. Okay, so what we need to do here is place the bar magnet, on a drawing sheet. Okay, now what you need to do is place compass at different positions, right? Place compass at different positions and mark the direction of the north south, right? That's what it deflects. So north south deflections, and then join the lines, right? Join the lines as in 12.4, right? If you join the lines, this is how it indicates. And what are our observations? The number one. So the magnetic field lines travel from which direction to which direction, guys? Magnetic field lines travel from north to south. Okay, so that's why this arrow is from north pole to the south pole. That's the observation. And what is the other observation? The field lines get depleted, right? Or the magnetic field strength that we have already learned. Say the magnetic field strength gets weaker or depleted as we move away from the magnet. Move away from the magnet. Right. So basically what we have learned in this session, so what we have learned is a current carrying conductor produces a magnetic field surrounding it. That is one experiment we have learned. Let's look at this. So activity 12.1 proves that the current carrying conductor produces magnetic field surrounding it. Okay, that's one observation. And then how those lines are, right? To know how those magnetic lines are formed, you need to place a bar magnet onto the drawing board, and then if you throw this iron filings, they arrange themselves because of the magnetic pull in a certain order. If you observe, they are basically in this form. What is that form? From north pole to south pole, they go like an what we call it as like in a epsilon path, eclipse path actually, right? And then the magnetic field lines are uh, move from north to south, and as we move away from the magnet, the magnetic lines gets weaker and the strength gets depleted. Okay, so that's our observation. All right, guys. So yeah, thank you all. That's all from today's session. Thank you all for your time, and I hope you understood this topic. And if you have any doubts, please contact me through my Urban Pro profile.